So hello everyone, welcome back to my channel Math Smart Tips. Today in this video we are solving the question the assignment problem of GATE 2022 mathematics. This is the question number 57, and not only the solution of this question, we also discuss the complete procedure to solve this type of problem. So let's start the video, and before starting the solution of this video, I am requesting you to all those who are new in my channel, please like the video, comment if you have any comment, any doubt in the comment section below, and don't forget to subscribe the channel. So let's start. So the question says that three companies C1, C2 and C3 submit bids for three jobs J1, J2 and J3. The cost involved per unit are given in the table below. So this is the table, that is we call this as the cost matrix. Then the cost of the optimal assignment is. Now to solve this type of problems, we mainly use the method Hungarian method, named as Hungarian method. So the Hungarian method says that the step 1 is, first we reduce the row and the column, that is we subtract the minimum element from the each element of the row of a row and all row, and then simply reduce the minimum element from each column. So after completing the step 1, we go to step 2. The step 2 says that examine the rows one by one until a row containing exactly one zero is found. Mark that zero and cross all zeros in the column in which the assignment is made. Now step 2, also the B part, says that an identical procedure is applied successfully to the column, that is this is for the row and this is for the column. And now continue the successive operation on the rows and columns until all zeros have either been assigned or crossed out. That is, now two cases may arise. Case 1, all the zeros are assigned, and case 2, at least two zeros are remained by assignment in each row or column. In this case, we try to exclude some of the zeros by trial and error method. Now after step 2, we check the optimality condition, that is optimality test is case 1, if the number of total assigned zeros equal to n, then equal to the order of the cost matrix, then the optimality condition is satisfied, that is this is the optimal solution. If the number of assigned zeros is less than n, then go to step 3. Now step 3 says that draw the minimum number of horizontal and vertical lines to cover all the zeros. Step 4, select the smallest element from the uncovered element and then subtract the smallest element from all the uncovered elements and add this smallest element to all those elements which are at the intersection of two lines. That is, suppose this is an element 2. If this 2 is intersected by two lines, then we add the minimum element to this element and subtract from all other elements, these two conditions. Now thus we have increased the number of zeros, that is our motto for the step 3 is to increase the step 4 is to increase the number of zeros. Now the step 5 says that go to step 2 and find the required assignment, check the optimality condition to get the optimal solution until the optimal solution is satisfied. That is, we repeat the process. So now we go to the problem. In our problem, the problem is the cost matrix is, I write the cost matrix here 10, 12, 8 and 9, 15, 10, 15, 10 and 9. Now the minimum element in the first row is 8. Therefore our first work is to subtract this minimum element from each element. So this is the minimum element. So if we subtract from each element of the first row, so we get 2, 4 and 0. Then 9 is the minimum element for the second row, so we subtract 9 from each element of the second row, so this gives 0, 6 and 1. And here also 9 is the minimum element for the third row, so we subtract this 9 from each element of the third row. So this gives 6, 1 and 0. Now we apply the same process for the columns also. So here it is 0. So if we subtract 0 from the first column, so it will remain same. So this gives 2, 0 and 6. Now here in the second column 1 is the minimum element. So we subtract 1 from the each element of the second column. So this gives 3, 5 and 0, and here it is 2 zeros. So 0, 1, 0. Now we get 3 zeros, that is each exactly 1 zeros in the first row. So we now apply the step, this step, continue the successive approximation identical. So we go to step 2, examine the zeros one by one until the row containing exactly 1 zeros. Now mark that zeros. Therefore we mark, I write this matrix here clearly. So 2, 3, 0, 0, 5, 1, 6, get the matrix 6, 0, 0, 6, 0, 0. So first row containing exactly 1 0. So we mark that zeros and cross the zeros in the respective column, that is we cross these zeros. Now the second row contain exactly 1 zeros, we mark that zeros, and the first column and first column does not contain any other zero, so it is selected, and the third row contains exactly 1 0, so it is also selected, that is it is assigned. So this is our J1, J2 and J3, and C1, C2 and C3. So company 1 assigned J3. So C1 goes to J3, C2 goes to J1, C2 goes to J1, and C3 goes to J2, C3 goes to J2. So this is our assignment, and the optimality condition is also satisfied. Here the optimality condition, since the total number of assigned zeros equal to n equal to the order of the matrix. Here our total assignment is 3 and the order of the cost matrix is 3 by 3. So optimality condition is also satisfied. Therefore the optimal cost equal to C1 goes to J3. So we take the cost of J3, this is 8, this is equal to 8. C2 goes to J1, therefore the cost C2 goes to J1 means this 9, since this is the J1 job, so this is 9, and plus C3 goes to J2, the cost corresponding to C3 goes to J2 is 10, so this is equal to 10. So this is equal to 8 plus 9, 17 plus 10 equal to 27. Therefore our correct answer is 27 for this problem. So 27 is the optimal assignment. So this is the answer of this problem. So how was the video? If the video is helpful, then please give a like to this video, share with your friends and subscribe the channel. And here an announcement, I decide that I will make some videos on some other topics, so I am requesting you to all, please do comments in the comment section below if you need any topic. So thank you friends, see you again in the next video. Thank you.